Hello everyone. So a very good morning to all of you. Up to the last lecture, means in this subject, which is the advanced manufacturing processes, we have completed 15 lectures. Okay, in which first lecture was based on just the content, that what content we have to be discussed in the semester or in this subject. Okay, so rest 14 lectures we have completed first unit. Okay, that is the advanced machining processes, or in other terms we are calling it as a non-conventional machining. Sometimes in the books it is written that unconventional machining process. So it is just in other names also, like we can just call it. So today we are going to almost from my side, I have covered all the non-conventional machining processes that is available actually in the practical works. Okay, so that we have covered. And today we are starting another second unit of this subject, which is the advanced casting processes. Okay, so this is lecture number 16, and first of all I will just discuss that what is the content of that on, and then we'll move to the what is the topic that we are going to discuss, that is the casting definition and the casting terminology. Okay, so let's start. So this is the content of that. This is the casting definition and the casting terminology. Okay, and apart from that, there are four processes. Now there are different types of the processes. If we simply say about the casting processes, but if we are simply talk about the casting, but here we are not talking about the casting processes that you have studied previously in the last semester. Okay, so that are these that casting processes are very basic, and maximum of the work, 80% of the work that can be done by these whatever the casting processes that you have studied in the manufacturing processes. Okay, but these are the some these four are basically the advanced casting processes. Advanced is like we are calling them due to two reasons, like we can simply say. First of all, if we say by name, if we say that vacuum mold casting, so here we are using the vacuum. Okay, and if like we are using the vacuum, it means that we have to create a negative pressure. So if we are creating the negative pressure, then we have to use a lot of elements. Okay, and the system is whatever the elements that we are using, that is in a systematic way. Okay, so that is a time consuming, as well as the lot of equipment is required. It means that money related issues. Okay, so money is means large initial cost is there. Okay, and again we have to think of that what are the applications for which we are using this vacuum mold casting. Okay, and apart from this, second is like if we have to produce the elements which is of either of large section, complex geometries, or in batch production. Okay, so if we have to produce that one, then we can use these advanced casting processes. Okay, so these are the basic casting basic sorry not, it's not basic, that advanced casting processes. Okay, so that we will discuss one by one in different lectures. Okay, that is a continuous casting process, vacuum mold casting, evaporative pattern casting, and the ceramic shell casting. Okay, so these are the processes, and if there will be any extra that you have not covered in the last semester or in this apart from these four, so that will also try to take that into miscellaneous topic. Okay, so that I forget to mention over here. Okay, so that also we will cover. Okay, now today in this lecture, I'm just briefing you about what is the casting definition and what is the casting terminology, because whenever because of the is I know that you have already covered in the fifth semester, so there is no need to go for it. But as we are starting, I'm teaching this one, so that's why I just want to brief you about this terminology. By the way, I believe that you are aware about of these terminology or these definition, but still it's my responsibility to cover this one. Okay, so today in this lecture we will cover the casting definition and the casting terminology. Okay, so let's start. So first of all, just first time I'm reading this definition. Then I will tell you that what the meaning, exact meaning of this definition is. Okay, so this is the casting definition, simple casting definition. That is, casting means pouring molten metal into a mold cavity. Pouring means we are pouring the molten metal. Pouring means there's a molten material we have and we are pouring it somewhere. Okay, so pouring means we are depositing somewhere. Depositing, that I will discuss later on. Okay, so means a pouring of the molten material means liquid metal into a mold cavity. We have some hollow cavity in which we are filling this molten material. Okay, of the shape to be made means whatever the shape that is required, accordingly we are making the mold cavity and then we are filling it into that. Okay, so shape to be made and allowing it to solidify. After the solidification, the desired metal object is taken out from the mold either by the breaking the mold or taking the mold part out. Okay, the solidified object is called as a casting. Now this is the definition. Let's move to that what exact meaning is it. So casting means here we have to use the molten material. Molten material means a liquid metal. Liquid metal is like metals. If we are talking about that, they are generally available in the solid only, but what we are doing, we are using these type of the crucibles into the furnaces. Okay, so this is the crucible. This is a complete is the crucible in which initially we have poured, we have kept some of the solid of yeah, some specific materials. Okay, and then we are heating it. Okay, heating it up to the melting temperature. Okay, or melting point we can say. So then this is the molten material. This is the molten material that so that once this is metal is melted, the solid metal is melted up to the melting point. Like if we are talking about the iron, then up to the 1534-35 degrees centigrade, and if you are talking about the aluminum, then 900 to 1000 degrees centigrade. So that is melted, and this is like when it will be melted, this material will be melted. It will become metal, means sorry, liquid in form. But when you will see it, it will be looks like this one. Okay, so lot of gases is coming out from these liquid material and it will become red hot. Okay, so this once this liquid material is become okay, this solid is become liquid, that time we are pouring it means we are transferring from the crucible to the some other places. So other places means we are calling it as a mold cavity or hollow part. Okay, so hollow cavity we are calling it as a means mold cavity we are calling. So now you can see that this liquid we are pouring into this one. Okay, so this is nothing but the this is mold cavity only. Okay, so this is a mold cavity. Okay, this is the mold cavity. So here if simply you can see that this is a kind of this kind of structure. Like this is from the outside throughout the periphery, like we are just making a solid cylindrical part. Okay, so outside surrounding of that, that is that mold cavity is created by the molding sand. So this mold cavity is created by the molding sand. Okay, so that molding sand is accordingly like we are using a pattern and then we are filling the molding sand surrounded to the pattern, and then in the cope and drag part, and then we are removing so that mold cavity is created. So this is the mold cavity that is created and we are filling the molten material into that liquid material. So it will be like completely fill, and once it will be fill like fill this geometry. So like from here it will be completely filled. So the solidification will start from the boundary. Okay, solidification will start from the boundary. Okay, so because that is first of all the liquid is coming into contact with the solid material, or as well as we can say that we are using the moisture also into the molding sand. So that is coming in like moisture is evaporated, but as that is coming in the contact with the moisture, these liquid material, so that will start solidification. Solidification means it will try to move towards the semi-solid or the solid solidification. Okay, so these boundaries from solidification will start from these boundaries and it will move towards the center. Okay, so this is how the material is gets solidified, means it will become complete solid, and when it will become complete solid, now we have to remove this this molding uh, the molten material which has been filled, or that casting we are calling now, it is as a casting. So this we have to remove this casting. So what we can do is, either if it is a single pattern, if it is a single casting, then what we can do is we just make it, just turn it around 180-degree, and then we can break it out. If it is not coming out, then what we can do is, we can just put it hammering from the outside, and then it is coming out, or still it is not unable to come outside, then what we are doing, we just break the mold. Okay, so what is the meaning is, of this definition? The casting means the liquid material, or that is means pouring the molten material, that pouring the liquid material, transferring the liquid material into the mold cavity. Okay, mold cavity means this one, of the shape to be made, means whatever the shape that is required, accordingly, in which we are, first of all, we are creating a mold cavity, then we are filling the molten material. Okay, allowing it, and allowing it to solidify, it means till it become complete solid. Up to that we are keeping it inside, and after the solidification, the desired object is taken out from the mold, either by the breaking the mold, means if it is just a molding sand and single pattern, then just break it, or it can be taking a part. So, or the taking the mold part, means just take it out, means just shake it and just make it out. Okay, so this solidified object is called as a casting. So this is, now this red, this, sorry, this white one, which when you will bring it out, we call it as a casting. Okay, or in other terms like casted product, we can say. Okay, so this is the casted product. So this is the exact simple definition of the casting. Okay, guys, so let's move to the elements, that what are the basic components, or what are the basic components, or how the casting exactly took place. So first of all, I'm just briefing that what are the elements, and then we'll move to the that how it actually occurs. Okay, so these are the, like you have seen the trunk. Okay, trunk means जो घर में clothes जिसमें रखे जाते हैं, like पेटी जिसको बोलते हैं. Okay, so that is a trunk. Now trunk is generally has two part. Okay, so trunk is like this one. Okay, this is the bottom part, we can say, and generally the top part is very small. Okay, but just try to assume that we are keeping this center line, we are keeping this line at the center, means the, if we are using both parts in equal. Okay, like we are assuming like that. Okay, so if we are using like that, then only this setup only we are using into in the casting. So this is a center line, or here we are calling it, this center line, as a parting line. Parting line means which is dividing the top part and the bottom part. Okay, now here the top part is called as a cope. Okay, this is a cope. Okay, and the bottom part is called it as a drag. Okay, so sometimes this question can be asked that we are using three parts as well. So third, what we call the third part, if this is the third part. Okay, so this is the cope. Okay, and this is a drag, and this is the third part. Now this parting line should be divided equally to this third part, which we call it as a cheek. Okay, so this is a cheek. Okay, now if in case three elements is required, then we call it these are the three elements. Okay, but here I'm just using two only. So this is a cope and this is a drag, parting line which is dividing equally both cope and drag equally. Okay, so next is we are starting with this one. So here it's like okay, so here is the this is completely filled with the molding sand, we can say. There are different types of the means molding sand also have its own properties. So that we are not going to discuss, because that is not that I think you have already covered that into the manufacturing technology. So there is no need to repeat that one. So this is a completely fill of molding sand. This blue color is basically it's a molding sand. Okay, and if I simply say it is a combination of, first of all, that is a silica sand, which is largely and vastly available in free. Okay, so that is a silica sand. Okay, secondly, we are using the clay binders. So clay binders like kevlonitic solution, or we also call it as a fire clay. Apart from that, this bentonitic solution is also available, so that we are mixing along with that. And sometimes if we need the moisture, then we are adding the water into that. So accordingly the properties will changes. So how much percentage of the water we are adding into that. Okay, so accordingly we are changing the properties, the like green sand, loam sand, there are different types of the sands that you have gone through. So I'm just writing over here that there's a molding sand. Okay, now what are these elements that apart from this one? So initially we are starting the this is the pouring basin, which is in the beginning of the casting itself. So this is the pouring basin. Okay, and after the pouring basin, this is a sprue. Okay, so sprue we are also keeping at as a taper in section. Okay, why we are using taper section of you all are aware about, but just I will just tell you that why we are using this one. Let me finish this one first. So after that, we are just using this skin bob. Okay, which is a we can say like semi sphere kind of things, but that is open from both the sides, from here as well as from this side. Okay, so after that, there is a runner which is a horizontal passage. Okay, this is a runner which is a horizontal passage, and after that we are just reducing the diameter. Okay, so diameter is reduced, so we are calling this entity as a gate. Okay, this as a gate. Gate is generally it's a kind of door only. Door means we are entering into the room or we are exit from there. Okay, so here we are calling it as a gate because whatever the molten material that is just entering into the mold cavity from the casting elements. Okay, so this is after that we are using this mold cavity. This is a mold cavity. This is a complete is a mold cavity. Okay, this is a complete mold cavity. So it means that if we are filling the molten material into that, so it will be completely filled, right? So if I'm saying that from top view, when you will see this is a circular in cross section. Okay, this is a circular in cross section, this mold cavity. Then which shape can be possible? That once it will be completely solidified, this is a cylinder. Okay, so this will become complete solid cylinder. So after this mold cavity, we are just keeping a riser over there. Okay, so that whatever the liquid, once it will be completely filled, this mold cavity, whatever the solidified or the liquid material is there, that will come out through the riser. Okay, then we are also using the gas vent. So gas vent can be used at the mold cavity, or sometimes we use at the gas this gate, or sometimes we also use at the runner. So gas vent is nothing but it's like whatever the gases that is we are using the liquid material which is at a very high temperature, and they are generating the different types of the gases. So we do not want that these gases or whatever the air that is entrapped during this sprue, that will become a part of this casting. So if it will become a part of that, then it will create a casting defect, that is a porosity. Okay, so we do not want that, because of that the strength of the casting element is decreases, so we do not want to that. So for that only we are using gas vent. So gas vent is used to prevent uh, the casting defect or to entrapment of the gases. Okay, so these are the elements. Let's discuss how actually the casting is occur. Okay, so first of all, this is a pouring basin. So here we are using the ladle. Okay, so ladle means through which the molten material is coming, or crucible we can say. So this crucible through which we are pouring the molten material. So pouring the molten material is like here we are not using like a tape is there in the bathroom, and we are just keeping a bucket over there or bottom to that tap, and that once the water is falling into the bucket, now that is spread suddenly. So here it's a casting, it's not a water which has whatever the liquid material that we are using, it is it at a very high temperature. So we do not want any kind of spread. Okay, so because it will damage operator as well as the elements. Okay, so we do not want impingement, means that we do not want, we are keeping this ladle, the distance between this ladle and this pouring basin, this surface is very small. Okay, so we are just taking it nearby so that there will be no spread. Okay, so once this liquid pouring molten material is coming over that, sometimes exactly this pouring basin shape is not like that. Some its shape is like this one. Okay, like this. So when you are pouring when we are pouring this liquid material over here, first of all it is filling up to here. okay, and then it is start falling from not falling, but it is move along with the boundaries of this sprue. Okay, so that this will fall, this will travel the boundary of the sprue. So here this sprue exactly it's not like this, but it will be looks like taper in section. So why we are using this taper? Because is you can see that this liquid material which is coming along with this boundary of this sprue, so that has a very small cross section area. Okay, so we want that whatever the cross, when this liquid material will reach up to this section, this cross section, okay, exit of this sprue, then it should be completely filled. If it will be completely filled, then there will be a no entrapment of the gases, means whatever the air that is coming over here, they will be due to the pressure difference that they will move out. Okay, so we do not want the air entrapment over here. So just to avoid this defect, we are using the section, this taper in section, this is sprue. Or some of the books we also you can also read that to avoid the air aspiration effect, to avoid the air aspiration effect. Okay, to avoid the air aspiration effect, or to avoid the entrapment of the gases, we are using this taper in section. Okay guys, so now we know that here the cross sectional area is high, but here it will become less. So whatever the liquid material that is coming along with this boundary, this will be become like it will become like this, and there will be no gases which is passes through the skin bob or towards the runner. Okay, now whatever the liquid metal which is coming from here, they will now fall in the skin bob. Okay, this is the skim bob. Okay, so now it is filled, and once it will be filled up to this one, now it will travel towards the runner. Okay, because it is a horizontal passage, so it will move towards this side. Now there is a possibility that generally what if if we are talking about a 100% material, okay, means any of the material which is containing itself as a same element, so there is no need to classify. Okay, but if we are using the alloys, then if we are melting the alloys, or we are using the molten material of the alloys, then there is a possibility that whatever the high density particle is there, now this is a horizontal passage, okay, and that is in the liquid form. So whatever the high density particles is there, molecules is there, they will try to sediment over here. Okay, bottom part of this runner, and whatever the low density particle which is in this region, they will try to move towards the upside. Okay, so there is a possibility that this kind of formation can be possible, like not formation, but the bifurcation can be possible. Okay, so what sometimes we can use the vibration kind of things, so that these small density particle should move toward this side, and high density particle should move toward this side, and then only as continuous this liquid metal is coming, so that because of that pressure it should move towards the gate side. Okay, now after that, after this runner, we are using this gate. Okay, so as you can see that the cross sectional area has been become reduced. Okay, so this cross sectional area is reduced due to which the velocity is increases. Okay, this velocity is increases, and as the velocity is increases, it is fallen up to here. Okay, like this, if this is the mold cavity, so now after the gate it is entered into the mold cavity. So as it is coming to the mold cavity, now it is first filling this area. Okay, so first up to filled it this one. Now is the liquid material is coming continuously coming, so up to it has been filled up to this one. Now here the concept is like is the liquid material is coming, and this will obviously, because this material has been already filled. So what will happen, the liquid material which is coming after this, just now, like for an example, up to this material is filled, and liquid material which is coming after this, so they will basically try to push it upward. Okay, so what will happen that whatever the material that is over here, or that has been reached up to here, is this is only the layer by layer only they are moving towards the upside. Okay, layer by layer only they are moving the upside. Okay, because it has a very low density. Okay, sorry, high density and low viscosity. Okay, so they will not like move towards the downside and then it will come upside. So what is it is we are moving toward the with respect to the time, then whatever the molten material that has been filled initially, they will try to become solidified. Okay, so that's why it is the top layer only, it is moving toward the upside, and the new layer, which is new layer means new molten material which is coming, they will try to push this one. Okay, so whatever like the molten material that is once it will be completely filled this mold cavity, after this material is coming out from the riser. So this cross sectional area through which only we are removing the molten material, we call it as a riser. Now here one question can be possible, one question can be, you can ask that there is a possibility that whatever the molten material means, what kind of the shrinkages that can be possible, means what kind of material, because when we are talking about the throughout the process, here there is a three possibilities. The material is in liquid form, the material in the semi solid form or solidification we can say, or metal is in the solid form. So when the material is coming out from the riser, it has two properties, which is like shrinkage allowances, sorry, it should be like a semi solid or it can be a liquid. Semi-solid and the liquid. So I hope that the two things that you have studied, that what types of the allowances that is affiliated with the riser. So first is liquid shrinkage, and with respect to the semi-solid, that is a solidification shrinkage. So that's why these are the two allowances which is affiliated with the riser. Now if we are talking about these mold cavity, then here it is in the liquid form, but whenever you will take this mold out from the this casting from out from the mold cavity, there is a two possibilities. First is either it can be completely solid, or second is it's not like it can be completely liquid, because if it is a liquid, then we cannot come it we cannot bring it out. Okay, so another possibility is it can be a solid and it will be a semi-solid, means combination of both these two, because as I said that the solidification should start from the boundaries. So if it is starting from the boundaries, then if there is a small amount of the liquid material inside the at the center line, then it is manageable. That if you have to produce the number of component at the same times, so it's like once it will be solidified from the boundaries, then just take it out and just make it another mold. Okay, so like that also can be possible. So if we are talking about the mold cavity, means if there is a question that can be asked like what are the allowances that is affiliated with the mold cavity, so it will be a solid contraction, it will be a solid contraction and semi matlab shrinkage allowance, because it's a semi solid. Okay, so semi the allowances which is affiliated with this, that is a solidification shrinkage. Okay guys, so please keep in mind this one. Now here is we are talking about the mold cavity that we are using, that is completely hollow. It means that when you will fill this mold cavity, it will become complete solid. So as I said that when you will see from the top view, it will looks like a circular in section, circular in cross section. So this is a cross sectional area. It means that whatever the length is there, this length, this complete length, height you can say, and this is the diameter. So this is what exactly, this is the solid cylinder. Okay, d diameter and h height. Okay, so this is a complete solid cylinder. Now what we have to do when we have to produce the hollow casting? Okay, so for that I'm just okay, so before going to that, I'm just briefing that what are these terminology that this I want to take this one. Okay, so first of all, the pouring basin. So what is pouring basin? Pouring basin is nothing but it is just we are filling the molten material from the ladle, and it will transfer the molten material to the sprue. Okay, so what's written? It's a small funnel shaped cavity at the top of the mold into which the molten material is poured. Poured. Okay. Next is the sprue, that is a passage through which the molten material reach from the pouring basin to the mold cavity, or some mold cavity is written because there are different types of the gating system is there, top gate, bottom gate. So that depends on the that which gating system we are using. So in other terms, we can write that it by using this sprue, we are just taking the molten material from the pouring basin to the runner or skim bob, we can say. Okay. Next is the runner. So it is a horizontal passage or channel, we can say, through which the molten material is carried out from the sprue to the gate. Okay. The gate is the channel through which the molten metal enters into the mold cavity from the runner, we can say. And then is the riser. So riser is a vertical column, we can say, of the molten material placed into the mold to feed the casting as it shrinkage and the solidifies. Okay, so when the molten material is coming out from that, we just stop the input or the material that we are pouring. Okay. Next is the gas vent. Gas vent is, as I said, that we are just using to remove or facilitate escape of the air and the gases. Okay. So otherwise, if there will be a no gas vent, then gases will become a part of the casting. So that will create a casting defect. Okay, guys. So now let's come to the as I said that what will happen when we have to produce the hollow casting, because in the last figure we used the casting, that figure we used, that is a solid casting. Okay. So now here we have to like this is a cylinder kind of things. Okay. Same, kindly consider the same, that is from the top view it is a circular only. Okay. So whatever the height that we are using, in that height basically we have to create a hollow cavity. Okay, hollow cavity means like for an example, I have this glass. Okay, so in this glass basically just try to assume that this is the mold cavity that we have created. Okay, this is a completely blank. Now we have to fill the molten material into that, but when we will fill the molten material it will be completely filled. Okay, so if I have to make the hollow in between, I'm not saying hollow throughout. Hollow throughout means it will become a hollow cylinder. Okay, it will, if it will be throughout, then it will become hollow cylinder, means from here to here it will become hollow cylinder. I'm not saying that. I'm just saying that we are just remove small amount, we just have to keep hollow in between somewhere. Okay, throughout this centroidal line, throughout this center line. Okay, so we have to keep up to some diameter or up to some height, we have to keep it hollow in the cross section. Okay, so if you will see the cross section of this one, that is also circular in nature. So what we have to do, this diameter, this cylinder, this, because this is also a circular in nature and some height, so that is also a cylinder. So we calling it as a core, core. Okay, this is a core. Okay, and this core is placed where we have to create the hollow cavity, means hollow casting we have to produce. Okay, means where we do not have to keep the molten material. Okay, so there we are producing. So this core is generally made up of the molding sand only. This is made up of the molding sand only, and this like this is also the molding sand, because that is, as I said, that this is filled with the sand only, molding sand. So that is also a shape of molding sand only. So now this is also the molding sand. So we are just connecting this molding sand, this core with this molding sand, we are just using the chaplets. Okay, so this chaplets is just used to connect the core with the molding sand or external boundaries, we can say. Okay, so now we are filling the molten material. Okay, so now we are filling the molten material. As the molten material will be filled, okay, then it is moving towards upside. Okay, and this is completely filled up to this. Okay, sorry, this is not outside, this is inside only. So this is completely filled. Now here you can ask me, please do not look as per the geometry, that from front view only you are watching. So if you are watching from the front view, then you can ask me one question, that sir, how this material is going towards this side. Exactly, it is not this just a rectangle only, it's a this cylinder bar. Okay, so somewhere only we are keeping the chaplets. Okay, now here two questions can be raised, that okay, let's we have filled this one, and first question is how we will bring this core out, because we do not we are just we just use this core to create a hollow cavity. Okay, so how we will bring it out? And the second question is how these chaplets will be removed, whether there is a possibility of removal of these chaplets or not. Okay, so first question is answer of the first question is that we are when we are using the core, so what we are doing this, once it will be completely this solidified. Okay, so after that just we are using a small drill bit. So just find out that where is a small cross section, means small depth is there. So when you will see from this side, this is a this much height, and from when you will see from this side, this is this much height or length we can say. So just a small amount of the drill bit, just drill over here. Okay, so it will become a hole into the casting. Now we are just using a kind of instrument, okay, and just dig it inside. Okay, so when we are digging it inside, so this is a molding sand only. So and also the when the molten material is come into that, that will become a dry. Okay, so that when you will dig it, it will easily come out. Okay, means easily come out means the bonding will be breakage, and just make it like that. So the material will molding material is coming out. This not molding material, sand material is coming out. Okay, sand is coming out. Okay, so first is that one. Second is whether these chaplets can be removed or not. Okay, so this is basically just used to hold the core. Okay guys, so whatever the chaplets that we are using, that will not cannot be removed. Okay, if it can be removed, then complete casting will become be divided into number of parts. Okay, if these chaplets can be removed, then this complete casting can be divided into number of parts. Okay, so we do not want to make it like that, because casting if we are doing, so we want a single equipment only. Okay, so whatever the chaplets that we are using, that will be throughout, means that will become a completely part of the casting only. Okay, so if it will become completely a part of casting, then can we, if we are like if we are making this casting of the aluminium and we are using these chaplets of the ms, then is it a kind of casting that we can produce? No. So whatever like the aluminium, if we are producing the casting of the aluminium, then chaplet should also be made up of the aluminium only, whether from any grade, from 1000 to 9000, any of the grade we are using, like 6000 series we are using, then these chaplets will also become a part become of the made up of the same material 6000 series. Okay, and that will become a permanent part of that casting. Okay, so whatever the material for the casting purpose we are using, the same material we have to form the use for the chaplets as well. Okay guys, so this is the things that is required for the when we have to produce the hollow casting. Okay, what are the elements? Just look into that. So first is core. Here is the separate part. So core is nothing but a separate part of the mold made of sand. Okay, that is made up of the molding sand, and generally bagged used for the making of the hollow cavities. Okay, next is the chaplets. So chaplets is like used to support the core inside the mold cavity to take care of its own weight, means chaplets weight as well as the core weight. Okay, to overcome the metallostatic force, because metallostatic force means here that if we will just hold it like if we will just hang it, okay, then that just for the time being just hang it, and when it will be completely filled this molten material, so what you have to do is up to some time, like if you have filled this molten material, then when it will be solidified, okay, just wait for the solidification up to this one. So when it will be completely solidified and we are hanging this one, so now you can start filling. So when you will fill this one, this mold liquid material will not enter in this side. Okay, so that we have to avoid. Okay, so that is only the meaning of that metallostatic force. Okay guys, uh, just last example in this one, that because that two examples you will take you will see in the book as well. So this is separately I'm taking an example of that. So this is a kind of cone. Exactly, it's not a cone that circular in cross section. When you will see from the top view, that is a circular in cross section. Okay, that one. And throughout with respect to the length, this diameter is increasing. So when you will see like this, it will become a cone, but here we are not producing this part. Okay, so up to some specific length only we are producing. Okay, so we can say like a taper cylinder we are producing of different diameter. Okay, or with initially inside it has some hollow cavity. Okay, so this hollow cavity is there. So this is a core that is made up of the molding sand, and that is connected with the chaplets. Okay, and then we are filling the molten material into that. So like if we have to produce this type of the part, okay, then we are just using this is the core, and then it will finally looks like this. Okay, so this is the molding material, this black one, and this white one is basically the hollow cavity. Okay, so that hollow part that we have to left. Okay, so thank you so much guys, and in the next video, in the next lecture we will discuss about the continuous casting. Okay, so thank you so much.